Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests. And the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era, but in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Mertsoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse.
Name a desert. Let me guess. Sahara? Well, actually, no matter which one you thought of, I'm sure of one thing. It's located somewhere below this line. See, when we hear the word deserts, we usually picture dry, sandy, blazing hot places, and there's not a single one of those above 45 degrees north latitude, or below 45 degrees south. In the south, that kind of makes sense. I mean, if you leave out Antarctica, there's not a whole lot of land down there. But things are different above 45 degrees north. There are tons of land. Countries like Canada, France, the United Kingdom, and a bunch of others. And still, not a single desert. Actually, not a hot desert. Most of the major hot deserts are up in the northern hemisphere, near the tropics of Cancer and Capricorn. And the hottest ones are usually found between 15 and 30 degrees north or south of the equator. Just like the Sahara, where average high temperatures can reach up to 104 degrees Fahrenheit. Together, hot deserts cover almost 15% of the Earth's land area. But if our planet is packed with them, why doesn't a single one appear above this line? I mean, the 45 degrees north latitude. I'll explain. Let's divide Earth into 5 main zones. The polar regions are located at both ends, north and south. Right here, we have the 2 temperate zones. And finally, right in the middle of the globe is the tropical zone. Now, the line we're talking about sits in the temperate zone, in a colder area. Because the farther you go away from the equator, the colder it gets. Actually, the average annual temperature drops about 1.2 degrees Fahrenheit for every degree of latitude you move north in the northern hemisphere. And cold weather is the main reason hot deserts don't form above this line. It turns out that as you move farther north from the equator, the sun's rays hit the Earth at a more slanted angle. That spreads the solar energy over a larger area, which means less heat is concentrated in one spot. Basically, these regions just don't get as hot. And it's one of the reasons why countries like Finland are much colder than Colombia, for example. Another reason temperatures are lower in this zone has to do with something called albedo. Basically, this term refers to the amount of sunlight that a surface reflects back. Let me give you an example. Every surface on Earth both reflects and absorbs sunlight, but in different amounts. Take snow, for example. It can reflect up to 90% of the sunlight that hits it and only absorbs about 10%. That's what gives snow a high albedo. And it's totally different with sand, which has a lower albedo. In places like the Kalahari Desert, down in southern Africa, it's about a 50-50 situation. Most of the year, roughly 50% of the sunlight gets reflected around there, and the other 50% is absorbed. The heat absorbed by the sand is part of why it gets so hot in dry places like deserts. I mean, hot deserts. Simply put, sand soaks up more heat, while snow reflects most of it. This is one of the reasons why snowy areas stay much cooler. So the closer you get to the polar zones, the easier it is for sunlight to be reflected instead of absorbed. And that helps explain why there aren't any hot deserts around those parts. Then, we also have atmospheric patterns. Let's just say that the air patterns change a lot once you go above that 45-degree line. That's because this region is controlled by a wind belt known as the Ferrel Cell. Okay, so Earth has 3 main convection cells. You can think of them as big loops of moving air. Warm air rises, cools down, sinks, and then the cycle repeats. At the top and bottom of the planet, we have the polar cells. Right in the middle are the Hadley cells, and sandwiched between those two are the Ferrel cells. Now, everything that happens between these 3 cells can get a little complicated, but for today, the main thing to know is this. In those middle zones, the warm air that comes from the tropics meets the cold air from the polar regions. So, Ferrel cells play a big role in moving heat from the equator up toward the poles. This flow of warm air helps smooth out the temperature differences between the tropics and the polar regions. And that's what shapes the weather in places like North America, Europe, and parts of Asia. In the mid-latitudes, the Ferrel cell keeps the air moving around so much that hot, dry air doesn't really get a chance to settle. So, those regions end up with more moisture, more clouds, and even storms, rather than dry, desert-like weather. That's why you don't usually see hot deserts around 45 degrees latitude. Basically, what I'm trying to say is that the Ferrel cell makes the weather less stable. And that's very different from what happens in the Sahara Desert, for example. Over there, temperatures don't change all that much throughout the year. Just expect it to be hot. When you put all these factors together, it helps explain why hot deserts are mostly limited to the middle parts of the Earth, and why you'll never find a Sahara or Kalahari-style desert in places like Canada or Sweden. But that doesn't mean we don't have any deserts above the 45-degree line. Turns out, deserts don't always have to be hot and sandy. In fact, they can look like this. Yep, I'm talking about the Arctic. Because the actual definition of a desert isn't just some hot, dry, sandy place, it's really any area that gets very little precipitation. In other words, an area where it doesn't rain much. And it usually gets no more than 10 inches of precipitation per year. So no matter if the weather is hot or cold, deserts are really dry places with hardly any vegetation around. That makes it pretty tough for animals and plants to live in those environments. If you think about it, That means the biggest desert on Earth is Antarctica. It covers about 5.5 million square miles, just endless ice flats as far as the eye can see. It's also the coldest desert on the planet, even colder than the Arctic, which is the other polar desert. Temperatures there can drop as low as minus 128.2 degrees Fahrenheit. If you look at the Earth, about 33% of its land is desert. Now, pay close attention to the ones located between 15 and 30 degrees latitude. These are called tropical deserts. But can you notice something curious about their locations? Most of them are found on the western edges of continents. And there's a reason for that. Actually, 4 main reasons. First, the winds that bring rain usually blow from the east. When they move across the land, they drop most of the rain early on. By the time these winds reach the west side, they're dry, so there's no rain left for those areas. That already makes things pretty dry. Second, in the western margins of continents, the air usually goes down instead of up. When air goes down, it gets warmer and can't form clouds, so again, no rain. Third, if there are mountains nearby, they can block the rain too. One side of the mountain gets all the moisture, and the other side, called the rain shadow, stays dry. And lastly, the ocean near these places often has cold water. Cold water cools the air above it and makes it calm, so clouds don't form easily. No clouds means no rain. So when you put all of that together, it helps explain why those tropical deserts seem to prefer one side of the continent more than the other.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.